imagine a child in a normal environment, no special toys, no special radios, no television, just a normal environment of people, stones, cups, and pots. Then there is a major change around 2 to 3 months of age. Now the baby doesn't cry as much, starts to babble a lot more, and most important, reacts to surprise, because it is now able to recognize that that face, that voice, that posture, that toy, that's unfamiliar. I haven't seen that before. As a matter of fact, that's why you see this smiles to humans around 3 months of age. It's not that babies love human beings so much. It's that at first when they see a strange face, they're not sure that that's a face that they know, and then they assimilate it. They understand, oh, that's a human being. That resembles the face of my mother or my father or my older sibling. And we call that smile the smile of assimilation.
You remember me after all? It's me, Mom.
It's very important to appreciate that the child is learning new information every day, because that is the way it is. My lovely analogy is a well-fed seagull on a summer afternoon will just fly around. It has no reason to fly around, but that's the way seagulls are built. Human beings are built to seek new information, to learn from it, to consolidate that knowledge and move on.
Babies, therefore, are biologically programmed to seek new information. But how? How does the brain decide what is interesting and what isn't? By recording its electrical signals, Eric Kurshane is trying to pinpoint how the brain recognizes new information as the baby prepares to learn.
The baby's world is full of things that are changing very rapidly, sights and sounds. And what it has to do is reach out with its sensory system and with its nervous system and grab onto those pieces and try to hold on to them so that it can build a picture that's a continuous picture of things that are happening.
Normally, a baby is bombarded with complicated information. Kurshane's experiment simplifies its world. He explores how a baby's brain reaches out to distinguish between the familiar and the new. His electrodes pick up the brain waves evoked when the baby notices something different, unusual, interesting. In this experimental world, stimulation is reduced to a single, simple image, a human face. Kurshane flashes the face again and again until the baby is used to it. Then, suddenly, he changes the face.
We want to see at what age the nervous system is able to make distinctions between things it knows and things it doesn't know. We want to be able to see how infants come to decide what's important. What we're seeing is a process of the nervous system gearing itself up in anticipation that now here is a learning situation. This is new knowledge that might be coming my way.
Infants as young as 3 months old can make these crucial distinctions. In fact, their responses are actually far larger than those evoked in adults.
In children, it's a big response because they have a lot to learn. And they better get it right because it may be important for them later on.
Just bring Andy in here and put him in the...
That same response to new information can be seen not only in brainwaves, but in an infant's behavior. Leslie Cohen is trying to discover just how a baby's mind grows. He enters its world through a technique called habituation.
Habituation can be defined formally as a reduction in the infant's responding with repeated presentations of the same object or stimulus. But what that really means is if you show the baby the same thing over and over again, the baby's going to get bored, and he's not going to be interested, and he's not going to look very long at it. The reason the baby is bored is that he's experienced it before. But that, in turn, means that the baby has remembered something about it. We can exploit the baby's boredom to discover just what it is babies perceive and how that perception changes over age. For example, if we present a very simple stimulus like an angle, we can ask the question, what is it about that angle that a baby really processes?
First, Cohen habituates the baby to the angle. Then he shows it other angles. One is identical to the first. The second is the same angle, but it's turned in a different direction.
A third kind of angle would be one like this. Now, to you and to me, this looks like a very different angle, and it is. But in terms of the direction of each of those lines that makes up the angle, it's the same thing the baby saw before. We've got a horizontal line, and we've got a line going up in this orientation. Well, when we tested infants on this at 6 weeks and at 3 months, we discovered something very exciting. Those babies reacted very differently at the 2 ages.
The younger infants were bored with the third angle, when the lines point the same way. The older infants were bored with equal angles, no matter which way they were turned. In 6 weeks, their minds had gained the ability to grasp the abstract concept of an angle. Then Cohen tested infants using stuffed toys instead of angles to see if they could form concepts of more complicated objects.
If you think about psychological wisdom in the 1950s and 1960s, people were saying that in order to form categories, people had to have language, and they used labels in order to group things together. We and others who've studied categorization in infants have shown that's clearly not true, that babies can form them at a very early age. Imagine an infant who could not form some simple concepts and categories. Every time that infant saw a different person from a different point of view, it would be totally different. That baby would not survive in this world. The world would be totally chaotic, and it couldn't learn from experience.
We are now beginning to understand the full extent of the cognitive capacity of infants. Research indicates that the infant mind is much more sophisticated than previously thought.